Now that we have looked at graphing in all three forms, we've graphed in standard form, ax squared plus bx plus c, we've graphed in vertex form, and we've graphed in factored form, we are going to then take this a step farther and look at quadratic inequalities. Much like when we did linear inequalities, we have the inequality symbols. We still used dashed for the strictly greater or less than, and we used a solid for greater than or equal or less than or equal. Excuse me. And then for shading, we look excuse me. We look at which way the mouth is facing. Okay, so we go above the parabola if its y is greater than. If its y is less than, then we shade below the parabola. Now, in here it says step 1 is rewrite the parabola in vertex form. I personally don't think that's necessary because we have learned how to graph in all three forms. So we are just going to go straight to step 2, graph the parabola based on the form that is given to you. Okay, so let's look at the first two examples. We have both of these in vertex form. So in vertex form, we have to remember that we use the vertex and, if we can, use the y-intercept. So I'm going to find the vertex first. That's hk. So in this case, I have 3, -2. And if I plug in 0 for my y-intercept, I get 0 minus 3, which is -3, quantity squared, so that's +9 minus 2 is 7. So I'm going to graph these 2 points, and then I'm going to mirror the 0, 7. So I've got 3, -2, and then 0, 7. So I am 1, 2, 3 spaces away from the vertex. I'm going to 1, 2, 3 to the other side. Same y value. Now it is a strictly less or strictly greater than, so I'm going to make my parabola. Sorry, it's not a very good parabola. I'm going to make my parabola dotted, and then it's greater than, so I'm going to shade above my parabola, which is inside the parabola. Now, if you're not sure, you can pick a value to test. So maybe I pick the point 0, 0, and I plug it into the original inequality to see if it's a true statement. If it is a true statement, then that's where I should be shading. If it's false, then I shade inside the parabola. So if I did, I'd be checking, is 0 bigger than 0 minus 3, quantity squared, minus 2? Is 0 bigger than, and we got 7. That is false, so that's, again, confirmation that I need to shade inside my parabola. All right, let's do one more in vertex form. So I've got vertex is, in this case, -1, +4. And my y-intercept, if I plug in 0, I get 0 plus 1 is 1, squared is 1, but I've got a negative out in front. So I've got -1 plus 4 is 3, and I'm going to mirror that point. So I've got -1, 4, 0, 3. I'm one space away, so I'm just going to go over there. And it's greater than or equal, so I'm going to make my parabola solid. Okay, and then it's greater than or equal to, so I'm going to shade above. So that's everywhere outside of my parabola. That means that all of these points satisfy this inequality. All right, I would like to look at y is greater than x squared plus 4x minus 5. Okay, I'm going to do one of these in standard form, and then I'm going to factor one of them so that you can see how to do these in factored form as well. Okay, so we're going to go ahead and do this first one. I'm going to go ahead and do these both in standard form, and then I'll give another example that we can do in factored form, just so that you can see that being done. Okay. So, in standard form, we knew that the vertex is the x value is -b over 2a, and then I have to plug that back in. So for this one, I have -4 over 2 times 1, so that gives me -2. So my vertex is -2, comma. So if I plug in -2 up here, I've got -2 squared is 4. Minus 8 is -4 minus 5 is negative 9. So I've got negative 2, negative 9 for my vertex. And then again, I'm going to find my y-intercept so that I can mirror that point. I get 0, comma, c, which is negative 5. So I get 0, negative 5, and then that's 2 spaces, so I'm going to go 2 spaces the other way. And it's a strictly greater than, so I'm going to make it dotted. And since it's greater, I'm going to shade above, which is, in this case, inside my parabola. Okay, now let's look at y is greater than negative x squared minus 6x plus 8. So my vertex, negative b over 2a. So I've got x is negative of negative 6. That's positive 6 over 2 times negative 1. So that's negative 3. So if I plug in negative 3, I get negative of negative 3 squared is 9, minus 6 times negative 3, so that becomes plus 18, and then plus 8. So I have negative 9 plus 18 is 9, plus 8 is 17. Now I don't have a 17 mark on here, so I'm just going to go out to negative 3 and say that that's up here. And then my y-intercept, if I plug in 0, I get out 8. So I have 0, 8, and I'm 3 spaces, so I'm going to go 3 spaces the other way. This is our negative 3, 17, and it's strictly greater than, so again, dotted. And I shade greater than, so that's above, so that's all the points on the outside of my parabola. These all satisfy the inequality. Alright, so we're going to make another example here for you in factored form. So what if I have y is less than or equal to 2 times x minus 3 times x plus 5. Alright, so I can find my x-intercepts in this case, and that's where we set each parenthesis equal to 0. Okay, so if I set each of these equal to 0, I'm going to get x is equal to 3, and x is equal to negative 5. So I'm going to plot those 2 points. I'm going to plot those 2 points, so I get 3 comma 0 and 1, 2, 3, 4, 5 comma 0. Okay, and then I know that the vertex is going to happen halfway between those points. So I'm going to take my x-intercepts and I'm going to add the negative 5 plus 3 divided by 2. So that's negative 2 divided by 2. So I get negative 1. And if I plug in negative 1, I'm going to get 2 times negative 4 times positive 4. So that's what's negative 32. Now I don't have space for negative 32, so I'm just going to mark it down here and call that negative 1, negative 32. It is or equal to, so I'm going to make it solid. Okay, and since it's less than or equal to, my shading is below, so that's everything outside of my parabola.